Alright, chemistry classes, we are now touching base and moving on from our moles chapter and moving into our next chapter, which will be chemical reactions. Just a little foreshadowing, we've done our mole chapter. After our chemical reactions chapter, we'll go to a chapter called stoichiometry, which sounds really scary, but it's actually just combining these two chapters together. Chemical reactions are something very, very important in the world. They happen in our bodies. It has to do with the food we eat. It drives a lot of the energy in the world. So what that really boils down to, this will be a few multiple choice questions you might see, but a chemical reaction is truly something, a process, chemically, in which a new substance forms something that is different than the original things we started with. So if I start with a glass of water and I add sugar, that's not necessarily a chemical reaction because I can undo it and get it back to what it was. However, if I take a piece of steel wool and I burn it, it definitely makes something that's totally new and different from what I started with. So a little terminology here. The things that you'll start with in a reaction are called the reactants. So in this example, we have a hydrocarbon. We're going to burn it in oxygen. The reactants are what I start with. What I end up making is called the products. It's kind of like in math. If we take 6 times 6, the product is 36. The products are what we make as a result of that new chemical reaction. A lot of times what we'll talk about is that the reactants come together and mix to yield the products or produce new things or make carbon dioxide and water. So just some terminology there. You'll see two different kinds of ways that we express chemical reactions. A lot of times in class we'll say that you need to be bilingual and be able to use both of them. Chemical equations are when we use formulas to show what happens, whereas a word equation, you'll have a quiz over this, is where we don't use the formulas and subscripts, we instead use the chemical names. So just to show you an example here, this is that one we just talked about. This is a chemical equation because we're using the formulas and the atoms of those molecules to show how they're reacting. If we take this exact same reaction though, the word equation is just like it sounds. It will be the words. So instead of saying C8H18, we'll say octane reacts with oxygen to produce, so there's my arrow when I go to write it, to produce carbon dioxide and water. You'll need to be able to work back and forth between these, and there's a few things we need to make sure we hit really quick. You need to make sure you remember there's 7 diatomic molecules. On the periodic table we said that is the hockey stick, and then there's the hockey puck, and the other thing is just that everything that ends in gen doesn't exist as one. It always exists in a pair, which is why we call it diatomic. So remember there's 7 of those. There's hydrogen, nitrogen will always be N2, oxygen, just like our last example here, will always be O2, and then all of the halogens will always be in pairs. So if it says plus chlorine gas, it's not plus Cl, it's plus Cl2, only when they're by themselves in reactions. Just so you guys know moving forward too, a lot of times we'll abbreviate reactions with Rxns. That's just kind of a chemist's lazy way of doing it. Other really quick things here, you will see in some of our reactions that we can express the phases of what we're using. So for instance, if I'm talking about magnesium, I know that that's a metal at room temperature, so I can go put a little subscript S down here because it's a solid. If I'm talking about water, not ice or steam, but water, I can go down and put a little L subscript because that stands for liquid, showing the state that it's in. Likewise, we know carbon dioxide is a covalent compound. They're both right up the staircase. So we can go put a little G right there because we know that will be a gas. And then we'll have to have a little lesson over this. But when we put AQ, what that stands for is aqueous. And what that means is it's dissolved in water. Aqueous always has to do with a water environment. Fish live in aqueous environments. The word aqua in Spanish has to do with, it all goes back to that prefix aqua or aqueous, and it means something can be dissolved in water. Getting into our first lesson here, we will always honor the law of conservation of mass, and what that says is that we can't all of a sudden make up new things and we can't destroy things. We can only rearrange atoms. And what that really means in our chemical reactions chapter is that over here, for instance, in this chemical reaction I have right here, I can't all of a sudden end up with 2 silvers if I only started with 1. So what we have to go do is balance our reactions. And what we'll go do then is we'll say, well, that means we would have to start over here with 2 silvers. And now I can see that I start with 2 silvers and I end with 2 silvers. Now, obviously it's different, but that's what a chemical reaction is it's making a different thing. If we go through the rest of this here, this reaction is now balanced from what it was, and I can go see I have one sulfur here and one sulfur here, so that's great. But I have two hydrogens here, and I only end up with one hydrogen, and that's not honoring the law of conservation of mass by balancing the reaction. So if I go look at the complete product, I can now see here I have two hydrogens in this hydrosulfuric acid, and I end with two hydrogens, so I'm good there. I can see right here that I ended up with two nitrogens, which is great because over here this gets distributed and I started with two nitrogens. I have 2 times 3, I have 6 oxygens on the left, and if I go right here I have 2 times 3, I have 6 oxygens on the right. My 1 sulfur and my 1 sulfur and my 2 silvers and my 2 silvers. That is what your first module will be about, is all about balancing chemical reactions. And we need to make sure we understand there's 2 different numbers you'll see. Coefficients are like in math where it will just double or triple or quadruple the number of this molecule. We can change that. If I made this 2 a 3, it's still going to be silver nitrate. That's not going to change anything. This little number over here is called a subscript. Remember, submarines are below the water. Subscripts are written below the letters. And we cannot change these. If I go change this to a 6, for instance, then it's not silver nitrate anymore, and I can't do that because I know nitrate is always NO3. So we can go change coefficients to balance things, but we are not allowed to change subscripts because those are determined by the charge.